All right, the next topic we want to cover is a new object type, the list. So we've hinted at lists a lot. You saw it in the command line crash course. We talked about strings, which are very similar to lists, but we haven't gone through lists really in a focused way. So lists are super useful and common in Python. So typically, when we use list, it's to combine multiple items of the same type. You technically can have multiple different types of objects in a list, but typically we don't want to do that. We want to have a list that have all the same type, either all integers or all strings, etc. So we're going to see some different lists, and like I was saying at the beginning, a list is a type of an object, and it has certain properties that we can use. So we're going to see some of those. So first we're going to make a list of strings, which has just these 3 words, and we're going to print or just display the value of the list in our notebook just by typing that variable. So we wanted to get the length of the list. We can type len and then the letter. Remember, that works also with strings. Similarly with strings, just like with strings, we can index by position. So we can get the first element of that list, which is index 0. We can also slice the list. So in this case, we're slicing from the beginning, just indicated by that colon, to the last element, which is -1. So when we create that, remember, we're going up to, but not including that last that second index that we provided. So we get everything but the last element of that list. We can also concatenate lists. So this plus operator, remember, it works with numbers, it works with integers and floats, and it will just do addition. It works with strings, so it'll concatenate strings. It also works with lists, so it will concatenate lists. So if we have a list with 3 elements and another list with 3 elements, and we add them, it will create a new list with 6 elements. So here we now have a list with 6 elements. We could also do it in the reverse order. But the list itself is unchanged. So if we wanted to change L, or if we wanted to take those 2 lists and combine them and make a new list, we'd have to store that as something. We'd have to say L equals L plus this new list, or we could say M equals L plus this new list. We'd create a new list. Another way we can create a new list is using this append operator. So append is a method of a list that allows us to add another element to the end of a list. So if we do l.append and then this string end, this will now add that element to the end of the list. And we also could have appended another list instead of just a single element. If we want to remove an item from a list, we can use this pop method. So we can pop the second element of L, which is Charlie. So 0, 1, 2. Element number 2 is Charlie. If you pop that off, and now L no longer has that element. So this append and pop methods, they do change the list. We can also we also have this method called insert. So we can specify the location we want to insert a new element. And now we have, in position 2, we inserted this element, which is a string called middle. We can also replace an existing item using a position. So we can say, instead of inserting, we can just change whatever the value is. So we can say L position 2 is now going to be XXX. So now we've changed this word middle to XXX. So we're going to create a new list now called M. And M has got these three strings, BB, AA, CC. So the list object type has a method called sort. So sort will change the order of the list to put them in alphabetical order. So now M has been changed, so now it's alphabetized. And we can also reverse that list, and so now it's in reverse alphabetical order, or really just reverse of what it was before. Another thing you can do with lists is you can make nested lists. This is kind of like a matrix. So you can say, here we're going to create a new thing. We're going to create something else that's called M, which is not what M was before. So M is going to be a list of lists. So M has a length 3, and each of those elements is itself another list. So this doesn't violate our kind of self-imposed rule that lists should be composed of the same thing, because this is now a list of lists. So if we look at M, we can see it's a list of lists, and then if we want to index or pull out values of M, we can use the same kind of indexing where we say, okay, if I want M position 1, that's going to be the second thing in M. That's going to be this list. So if I wanted to actually get a value from that list, I could do M position 1 and then just stack right on top of that the index of that element, because M bracket 1 refers to this exactly. So how would I get the second element, or element with index 2, which is the third element actually of that list? I would just put another bracket with a 2 there to get that 6. Now, in practice, this isn't how we're typically going to do matrices, right? We'll either use NumPy or Pandas. These are packages that are more built for numerical computing. But this idea of indexing in a kind of a serial way is very useful to kind of wrap your head around. Another thing that we can do is we can slice lists. And we saw this with strings as well. It's the same exact syntax and same idea. So we're going to make a list from 0 to 9. So we're going to say x equals list range 10. So this is going to give us this range object, and we're going to convert that to a list. So if we wanted the first 5 elements of that list, we can say x from 0 to 5. Or the shorthand would just be x colon 5, which will give us everything from the beginning up to, but not including, index 5. So it'll give us 0, 1, 2, 3, 4. Same idea in reverse. So if we want the last 5 elements, we can do -5 colon, which is -5 to the end. So remember, just like strings, we can count forward and we can count backward. So this gives us the last 5 elements. Or we can get just an internal slice, so from the second element up to 5. So this would just be 2, 3, 4. Okay, so the last thing I wanted to cover with lists is what's called a list comprehension. This took me a while to get used to, but once I figured it out, it's really amazing. Actually, it allows you to do some really cool stuff. So what we're doing with the list comprehension is we're combining 2 ideas, which is lists and for loops. So let me show you an example. So what we're going to do here is I'm going to show you an example without a list comprehension. So this is going to be a block of code with 3 lines. First, we're going to say this. We're going to create this list called squares, which will be an empty list, and then we're going to say for x in 1, 2, 3, 4, 5 this list. So for x in this list 1, 2, 3, 4, 5. So for every, we're going to go through this thing 5 times. We're going to say squares.append. Whoops. Squares.append x star star 2. So we're going to take x, which is going to be 1, 2, 3, 4, and then 5. We're going to square it and append it to this list. So this is a good thing to understand what it's doing. This is very handy. You will use constructs like this all the time. And it gives you this new list, 1, 4, 9, 16, 25. So this is the square of 1, 2, 3, 4, 5 as a list. However, in Python, there's a way to do this in a single line instead of in 3 lines. So when you read this line, it's kind of confusing, but basically you're saying squares will be stored as x squared for x in 1, 2, 3, 4, 5. So I like to read this kind of backwards. So just like with the loop, for x in 1, 2, 3, 4, 5, then do this. So you can read the for part first. So for x in 1, 2, 3, 4, 5, it's going to give me x squared. That whole thing is then wrapped in brackets, so it's a list, and then it can be stored as something else. We store it as squares. So I execute this block and then see what it evaluates to. It's the same thing, but I was able to do this in a single command, and there's advantages to that, to being able, because you can now take this whole thing and store it here. I don't have to make a whole other loop and create all this. I didn't have to initialize this list as an empty list, etc. So this would work, for letters too. So let's say I want to, have a list with each letter in the word spam repeated. So I can say C times 2 for C in spam, and C is just a just a variable that will stand for each letter in this string. We can also do this in using this sort of double indexed or matrix style thing. So I can say column 2 would be row 1 for row in M. So for row in M is just going to give me each of these elements of M, and then I'm going to get the middle element, which is the position 1 of that, what I'm calling a row here. So column 2 will now have 2, 5, 8 after I run this list comprehension. Similarly, I could create a new column where I'm doing something, so I can say row 1 plus 1 for row in M, and now I've created a new list that has this plus 1 for each element. Another thing you can do is you can add an if statement to the list comprehension. So this is where it starts to get pretty interesting. So we're saying I want row 1 for row in M. Reading backwards maybe isn't the best advice. I think probably the best advice for these is to look for the for statement. So for something in something. So it's going to give me this row 1 for row in M, but only if row 1 mod 2 or modulus 2 is equivalent to 0. So this is going to filter out the odd items. So it's giving me this. It's doing the same thing we did up here, but it's only giving me the elements that are even, that evaluate. So we're actually pulling out this element twice. we're saying row 1, blah, 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 for this thing, if that same element is mod 2 equal to 0. Another thing we could do is we could iterate over 0, 1, 2 and pull out all of the elements in this list of lists that have the same row and column. So this is 1, 5, 9. So this is going across the matrix. This is yeah, again, it's a very powerful thing. It takes a little while to like wrap your mind around because lots of other programming languages don't have this at all. But oftentimes it's the easiest way to do something in Python.